All right, everybody. Well, welcome back. I hope you enjoyed your break. And we are going to continue with lesson 6, right where we left off in the last video. If you are new here, if you just clicked into this video, be sure to take a look down below in the description. We've got a link to part 1 of this video so you can get all caught up. So what can get a little bit tricky here is the idea of where to sketch the geometry for this cut revolve and how to still have it related back to the screwdriver, because we're not going to actually convert the edges of the screwdriver. We're just going to kind of mock something up that'll get us pretty close, because that's all we really need. We don't need to spend a lot of time, and maybe this part that we brought in is a little too detailed. Like, we don't need all these little ridges from the screwdriver to be part of this cavity. So instead, what we're going to do is we're just going to kind of trace, but we still want to reference the screwdriver. So what we can do is we can create what's called a mate connector. And the reason we're going to create a mate connector is because you can begin a new sketch and use the mate connector almost as a sketch plane. So when we go to create this mate connector, we're going to put our mouse up here kind of in this spherical area at the head of the screwdriver. I've noticed that if it doesn't work, if you can't get it, it's sometimes helpful if you hold the shift button on your keyboard, but it looks like it's working for me. So I'm just going to left click here, and this is exactly what we want from our results. Our mate connector shows up here. It's got this like planar, it's almost like a planar disc there, and that's going to give us a plane that we can sketch on, and that is what we're going to do next. So we're going to hit the green check mark here to create that mate connector. So there we go, that looks good. And then what we can do is we can click on that mate connector, and then we can S key begin a new sketch. And you can see here from the sketch 2 kind of a plane preview, that plane is cutting right down through the middle of that screwdriver, and that is exactly what we were hoping for. Because now what we can do is we can kind of mock up a sketch for a cut revolve, and then we can just scoop out that block with that cut revolve. And the one entity that we're going to convert here, or that we're going to utilize here, is going to be this domed face. But instead of doing a convert, we're going to do what's called an intersection. So you click intersection here, and then you take your mouse over that domed face and you left click, and you'll see that that takes that arc, wherever that arc is intersecting with the sketch plane, and it converts it into the current design, into the current sketch. The reason that we did that is because we wanted this anchor point right here, because that's what we're going to anchor everything in our sketch to. So let's go to that anchor point. Let's S key begin a line command. Maybe we could press Shift 5 to get into a top view here to make this a little bit easier to see what we're doing. And we're going to click on that anchor point. We're going to move up in this direction. We're going to single click, let go of your mouse. You can type in a dimension there. Let's make that dimension 21. We're going to move over here in this direction. We're going to single click. We're going to type in a dimension there. Let's type in a dimension 17. We're going to move down in this direction, like so. We'll move down to about here. Single click. We're going to type in a dimension 112. We're going to move over here in this direction. Single click. We're going to type in a dimension 8. And we're going to move down here in this direction. Single click. We're going to type in a dimension here, 67. And then we're going to move away, come back, touch the end point, come back around this way like so to give ourselves kind of like an arc shape. Single click. And then we're going to move over this direction with a horizontal line. Single click, and you're going to hit escape. Whoops, looks like that line might not be horizontal. Click on it, H. There we go, horizontal. We're going to take this point here, which is the center of this arc down here. Take this point here and this line, and you're going to press I, which is going to be coincident. We're going to make them coincident. And then we're going to do the same thing with this end point here. Take this end point and this point right here, and we're going to press I, which is going to make them coincident as well. Now, this is a very simple sketch that I've created here, and I would probably take the time to get a lot more detailed with this sketch, but I'm just trying to illustrate to you that you don't necessarily need to trace every little nook and cranny of these parts. If you're trying to make a desk organizer, maybe you want it to be a little bit looser, because then you could put in different size screwdrivers. As long as you get kind of the key features included there, you should be good to go, but it's certainly up to you if you want to get more and more detailed. Like, maybe I would put in a fillet up here in this corner, and maybe I would put in some other little kind of detailed features on this part. In fact, I might make a fillet there anyway, just because I don't want it to end up protruding outside here. So maybe I will add that fillet. So I'll click on the sketch fillet, click on that corner there, and let's give that a radius of 6 millimeters. Okay. Good. We're done with that sketch. Let's turn that sketch into a revolve now. So we're going to say revolve, and then we're going to say that our revolve axis is going to be this line here going right up through the middle, and this will be a remove. And there we go. That looks fantastic. That's exactly what I was expecting there from that Revolve. And that should give me a nice pocket to set that screwdriver into. So let's return to the assembly, go to assembly, and let's test this thing and make sure that it is in fact updating properly if the screwdriver happens to move around. So if I click on the screwdriver here and then I grab this arrow, so I just move it in one direction, and then maybe grab this arrow, so I just move it over here in that other direction. When I click in the background, I notice that Onshape does not automatically update. So that's actually a built-in function of Onshape, and that way you can move your parts around and get them exactly into position, and you don't have to worry about the software just automatically triggering an error. It waits until you make a call to update that context. And the way that we do that is we right-click here on this face, and then we say update context, and we're going to call that context 1. So update context, context 1, and look at that, the pocket moved right over to facilitate that screwdriver. So another thing that I've noticed with this screwdriver is if we look at it here from this end view, there's maybe a little bit too much meat. Maybe I made this thing a little bit too high. Maybe I don't need all that plastic when I'm 3D printing. And so what I could do here is I could go into my variable studio. So currently this sidewall here has a length of 25 millimeters for that sidewall. So I could go into my variable studio here and I could reduce that. Maybe we'll make that closer to like 22 millimeters. So 22 millimeters, enter, and you saw that this updated, you saw that everything updated here, but the block didn't update. Well, once again, we're going to update that using the right mouse button, update in context or update context, context 1. So we update that, and there we go. Now the block updated. That's what we wanted. But now we see another problem. The screwdriver is sitting up too high now. It's kind of too far out of the tray. I want that to be sitting a little bit lower. So I could click on the screwdriver. I could grab this arrow here and kind of drag it down, maybe drag it down about 3 millimeters, click in the background. And then once again, I can right click here and I can say update context. Whoops, click in the background, right click here. Once again, I can say update context, context 1. And we see that pocket went down a little bit. It kind of, you saw it widen out a little bit there. So I'm going to go back to a Shift 5, look at this thing from the top. I'm going to move this around just a little bit more, maybe move this back this way a little bit, move it back this way a little bit. And once we're done moving that, we can once again click here in the background and then right click and say update context, context 1. And that updates the location of that pocket. So the final things that I would do with this block here, if we return to this window with just the block, see, we don't need to see the assembly for everything. Maybe I would press P here to hide my planes. Maybe I would add in the fillets here on these corners. So S key fillet, I'll add in a fillet here on this corner and on this corner. What's the radius of that fillet going to be? It's going to be hashtag down, 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 or actually here it is, block, I didn't have to go down, block corner radius, enter, 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 and then I would do another one here, S key fillet, this top edge running around the top, and what is the radius on that going to be? Hashtag, and I'm going to go down here to block top radius, enter, and enter, enter, and then finally I might change the color of this block. So if I go here to the block, right click, edit appearance, I'll make this kind of this bright yellow that I've got here. The hex code for that is FB17, if you want to use the exact same color I'm using there. And so with that, we can return to the assembly, and there you go. We have constructed the first block in this desktop organizer. So the goal of that section of the video was just to show you that sometimes the only thing you really need is kind of a rough outline of the part. And if that's the case, you can absolutely do that, but you could still design in context. You could use tools like creating a mate connector there in the context of that part and still referencing the screwdriver. And that way you're creating a sketch that's running right down the center of the screwdriver. Now, in the next couple of sections, we're going to see some other ways that we can reference the geometry from the assembly. Tools like doing a Boolean subtract with offset faces, or tools like doing an exact trace using intersect once again, but maybe using intersect with an offset, or tools like using surface offsets. So we will get into those in the next video, but this was really kind of the heart of this video, getting through and creating that first block. So if you have any questions about this section, be sure to let me know down below in the comments. And if you like what you're seeing so far, be sure to hit the like button. All right, so now that we've created the geometry for that block for the screwdriver, we're going to move on and create the block over here for the hard drive and for the 4-color pens. So to accomplish this, we're going to once again create a new Part Studio, but we're going to do this Part Studio here using the Create Part Studio in Context button. Now for this one, I am going to turn on my keyboard cam because we're going to be using a lot of keyboard shortcuts as we are sketching, and I think it'll be helpful for you to see some of those keyboard shortcuts. So let's click on this button here, Create Part Studio in Context. Where should the origin be? It should be the same spot as the assembly origin. So we click the assembly origin, we click the green check mark, and now we see that a new tab is created down here at the bottom of the screen, Part Studio 1, and that is where we are working. So we are going to click on this face here at the very bottom of the red tray, and we are going to begin a new sketch just like we did last time. So we click on this, the S key, begin a new sketch here, and once again, we're going to take that bottom face and we're going to choose Use. And that way that becomes kind of our outer perimeter of this overall shape that we're creating. And now we're going to go into our top view, so Shift 5 here. And now we're just going to be creating a block down here in this corner around the hard drive and the pen. So we only need these 3 entities for the offset. So we pick these 1, 2, 3 entities that we just converted into this sketch, and we choose offset. And once we choose offset there on those, 1, 2, 3, we're going to reverse the direction of the offset, left click to accept the direction, and then we're going to type in here hashtag, and we'll go down here to offset distance, enter, enter. And now we can create a line that comes across the top here. So a line that comes across like this, nice horizontal line, and a line that comes down like so. I'll connect that down at the bottom in just a moment. And we're going to hit escape and create a dimension here that's going to go from this line to this line. And that dimension is going to be hashtag offset distance. So that way that offset distance is the same all throughout the project, and if we need to change it, we only need to change it in the variable studio. And so we'll hit escape here, we'll take this point and drag it down, make sure it lines up here on that offset entity, and now all we need to do is add a dimension here. It looks like maybe we have a little bit of room here in this corner, so maybe I'll make this block just a little bit wider. Maybe I'll make it like 70 or 75. You know, it looks like we have plenty of room here for that block for the remote. I think 70 is probably going to work out pretty good for this one. So now that I've got that block extruded, I'm going to change my view here a little bit. And I think because this one is holding up these components that are going to be vertical, I'm going to make this one go up just a little bit taller than the previous block. So S key extrude, or you can click the extrude command here, extrude, and then we'll bring this one up just a little bit higher. This one doesn't really need to be related to the tray, because I'm not really concerned about the tray. I'm more concerned about holding the pen and holding the hard drive upright. We don't want them falling over. So maybe I'll bring this up to like 34 millimeters. And it looks like, once again, I've got the wrong contour. Let me click in the background and press spacebar. So you click in the background and press spacebar, that clears your selections. And then you can just click here on this region to be extruded. So how do we know what the correct height is? We don't really know. We just have to kind of eyeball it up, use our engineering intuition. Maybe that could be a little bit higher. Maybe I'll make that like 38. Yeah, that looks pretty good there. All right, so now we're going to hit the green check mark, and that creates that block. And remember, this block has not yet been added to the assembly, so it's often helpful to rename the block over here. I'll call this one block 2, and then I'll also rename it down here. So down on the Part Studio, right-click, rename. I'll call that block 2 for hard drive. It's for the hard drive and the pens. And this one, I apologize. When I did the rename, it was kind of out of the way. It was behind the keyboard cam. So I renamed it here in the parts list. And the reason that's beneficial is because now when you click this button for insert and go to assembly, it's a little bit more obvious what you're inserting. You're inserting this part here from the Parts Studio or from the parts list. So we hit the green check mark, and now we've added that part into our assembly. Remember, that part is free to float around. So I'll just do it here to illustrate. It's free to float around. So I'm going to press Control Z, and then I'm going to do a group here, S key group, and I'm going to take these two components and group them together. That way this part can't move relative to the red tray. So that part's starting to look pretty good. I think now we're ready to add in the cavity for that hard drive. So let's go back to a right click here and we say edit in context and we say context 1. That takes us back into that edit mode where we can see this entire part. And then let's launch a Boolean command. So here's the Boolean command on your toolbar, or if you don't know where it is, you could do a search. I'm just going to grab it right here, right from the top of our toolbar here, Boolean. And this is going to be a subtract. And so the tool is going to be the hard drive. You just pick the entire part there. And then the target is going to be this block that we just created. And we're going to use the option here for offset. And then instead of choosing faces to offset, we're just going to say offset everything. So take that entire part and offset it. And currently it's offsetting with a distance of 5 millimeters. I think that's probably a little too much. I don't know if we want to go as small as the 0.8. That might be a little bit snug for our hard drive, but again, it just depends on your printer. You know, you know your printer better than anybody. Maybe you could go even more snug, maybe like 0.4, or maybe you need to go a little bit larger. You definitely want to take a look at your parts and see if there's anything sticking off. Like this particular hard drive has a couple of little feet that are sticking off, and they stick off by about 1 millimeter. So I think I'm going to make my offset distance here 0.6. That should give me a little bit of play, you know, to account for that that 1 millimeter, because it's 0.6 per side, so it'll be like 1.2 total. That should give me enough play for this hard drive. But again, this is going to be up to you. It's going to be up to your tolerances, your models. You know, how accurately did I make that model of the hard drive? If it's not that accurate, maybe I want to go a little bit more, maybe like 1 millimeter per side, just to account for the fact that it was a little bit sloppy while I was modeling it. So it's going to be up to you. I'm going to go with 1 millimeter here. Let's just stick with that 1 millimeter. And you can see here that we can hit the green check mark. And there we go. We were able to remove the geometry of that hard drive. That actually looks pretty good. I kind of like the way that looks. I think that's going to work out pretty nicely. So once we're done with creating that cavity shape, we can say go to assembly, return to the assembly here, and then we can kind of test this thing. Maybe we go Shift 5, look at this thing from the top. We could move the pen over a little bit here. Maybe it's getting a little too close to this edge, so we move the hard drive, grab the hard drive here, move it over, and oh, that's right, we can't move the hard drive because it's got the mate. So the hard drive here has this mate here, which is holding it in place. So what we could do is double click on that mate, and then we could change some of these dimensions here. So this Y -85, maybe we make it like -80. Get that down a little bit closer. And then for our X20 here, maybe this could be like X -25. Move that down a little bit further as well. And so that's how you can move this thing using that mate, using that fasten mate, as opposed to just dragging and dropping it. So we hit the green check mark. And now once again, just like before, the context isn't going to update until we right click and we say, right click, update context. So we're going to update this context. We'll call this context 1, and oh yeah, that looks good. That updated, no problem. So I like the way this is going. I think the next thing I'm going to do is I'm going to create a pattern for the pen, and then I will create the cavity instance for the pen, or the whole instance for the pen. But I think we're going to save that for the next section of this video. All right, so now you've seen an example of using a Boolean to remove the material from that block, and that is probably going to be the most common one that you're going to use. The one thing I want to call out to your attention is that because this pen has got so much internal information, because the screwdriver's got so much internal information, it actually becomes a little more difficult to use a Boolean in that application. So if your plan is to draw up some of your own parts, maybe you want to consider making a relatively simplified version of those parts and kind of think ahead about how much easier that's going to make it to do a Boolean. If we try to do a Boolean with some of these components, we might end up with internal geometry because there's cavities inside of these parts. There's cavities inside of this part. But with the hard drive, it was just a nice solid chunk of plastic. So it was really easy to do a Boolean because it's a relatively simplified version of the source model. So since we can't really do a Boolean with the pen because we've got that internal geometry, let's take a different approach with that one. So we're going to right click on this part. We're going to say edit in context, context 1. That takes us back into this view where we see everything ghosted. And now, very similar to what we did with the screwdriver, we're going to try to create a mate connector here that will act as a sketch plane so that we can exactly reference the intersection curves of this part running down into the block of plastic. And then we can use that geometry to do a cut revolve. So this is going to be very very similar to what we did with the screwdriver, but it'll be much more precise. It's really going to adhere to the geometry of the pen as opposed to just kind of a loose mock-up like we did with the screwdriver. So to accomplish this, we need to create a mate connector. If you don't know where the command is, you could always search for it. I always feel like I'm searching for it. So mate, just type in mate here, and then we've got mate connector. And then once we go into mate connector here, we're going to pick on this circular edge of the pen. Now, unfortunately, that does not give us the mate connector in the orientation we need. We need it to be more like in this orientation so that we can sketch on that surface. Sketch on that surface. But what we can do is we can click this button here that says realign. And once we choose realign, we can set our primary axis to use this edge of the block right here. And look at that. That is what we were hoping for. So now that we realigned that mate connector, we can hit the green check mark, and then we can choose that mate connector, and then we can press the S key and choose to begin a sketch on that mate connector. So what we can do with this sketch here is very similar to what we did with the screwdriver, but instead we're going to do it here with the pen. What we can do is we can fly out this menu for use, and we can choose this option here for intersection. So when we choose intersection, we can choose this face of the pen, and anywhere that the face is intersecting the current sketch plane, we get a sketch entity, which is awesome. But now we need to do that on the lower section of the pen, and we can't see the lower section of the pen because the block is in the way. Well, all we need to do is just hide that part. So just like we would do in a regular part studio, you know, we are in a part studio here, we could just click the hide button and hide that block. And so now we can get down and we can pick this face to use for that. We're still in this intersection command, so we could pick that face as well. And then we could maybe even pick this face and this face and this face down here. You know, if nothing else, that's going to give us some nice reference geometry that we can use when we're doing our offsets. So that finishes out that sketch. We can hit the green check mark. We could just call that maybe something like reference to pen. So Shift N here, reference to pen. Maybe we could right click on that sketch, and from the right click we could say edit sketch appearance and maybe make it like a red or like a magenta or purple here, something that's really easy to see as we are creating our next sketch. And so now once again we can pick on this mate connector here, and we can S key begin a sketch, and now we can start referencing some of this geometry. So this is going to be an offset for that pen clearance. So offset here for that pen clearance, offset here for that pen clearance. This could probably be a little bit tighter, maybe like 0.4. It doesn't need to be that loose. It just depends on what you're trying to do. Do you want to maybe potentially use a different size pen in there? If so, maybe you want to put in a little bit more clearance. So we could offset that. And then we could even offset these here. We could offset this, this geometry. Oh, sorry. Let's turn off, or let's finish that offset. I think I didn't finish it. There we go, 0.4. Yep. Okay, good. And then we can also offset this geometry down here. So we could do the same thing here, offset that, offset this, and offset this down here. And once again, we can make that maybe I'll make this one a little bit bigger, like 0.6. Okay, and finish that out there like so. And now what we can do is we can create a line here. This line is going to start directly above or directly below this point here. Maybe I'll just sketch a line from that point straight down through, and then I'll trim that off. Trim, trim. Okay, and we can take this arc here and extend it a little bit and trim. Trim that up there. And then we can create one more line here. I know I didn't really need a second line there, but I just made it because it was a little bit more convenient. So we can make a line here that comes up vertical and a line that comes over here like so. And then we can hit escape, and we can take this point and maybe make them coincident. And can we make this coincident to the mate connector, I wonder? Let's see. Oh yeah, like that. I like that. And so now we've got a perfect shape here to cut revolve. So we can choose revolve here. We can choose remove. And our revolve axis is going to be this line here going down through the middle. And then what are we going to be cutting through? Well, let's show that block again. And then let's choose that block down here in the merge scope. And there we go. Nice, nice, nice. That gives us a nice cut there to receive that pen. So we can hit the check mark, and there is that cut. We could rename that to something like cut revolve for pen. Yes, I like it. And now we can create a pattern. We can create a pattern of the pen, and we can create a pattern of that cut revolve. So let's go back to the assembly. Let's see what the assembly is looking like. And let's add in a pattern. But you know what? We're going to be using the same dimension in two different places. So you know what this calls for, right? This calls for our variable studio. So we go over here to our variable table, and let's create a new variable here. We'll call this one pattern distance. And then that pattern distance, let's start out here at 15 millimeters. Let's see how that ends up looking. And so now we're going to go over here to our assembly. And in our assembly, we've got this icon, assembly linear pattern, up at the top of the screen. So assembly linear pattern. And for the assembly linear pattern, the instances is going to be the pen. I think I can just pick it here. Yep, it gets the full assembly. The direction, we could pick, maybe I'll pick this edge of the main tray just because it's a little bit more consistent. And then I'm going to, because remember, we're going to fill it off this edge here. So I don't know if I want to create a reference and then fill it off that edge. I think this edge down here is going to be there pretty much forever. So a little bit more consistent. So let's see here. So for our distance, we're going to type in hashtag, and then we'll go down here to pattern distance 15. Nice. And then for our instance count, let's make that 3, and then let's reverse the direction of that. Okay. I like it. A little bit snug. I think those are a little too close to each other. So maybe I'll come over here to my variable studio over here, and maybe let's increase that. Let's make that more like 30. Let's see what that looks like. Okay, yeah, I think that works. I think that'll look pretty good. Maybe I'll move the original instance here, move this original instance over just a little bit. Whoops, move this over this way just a little bit. Yeah, and of course, you could get much more accurate, much more aesthetically pleasing results if you used actual mates. Remember, I just kind of eyeballed up the location of these. So we'll move that over like so, and then what we could do is click in the background, then right-click here on the block, and we can say update context and context 1, and that is going to update that context. So now let's go back to that part. So we've got this new part studio here, this block 2 for the hard drive, and let's create another linear pattern. So linear pattern here, entities to pattern. We're going to choose this. Actually, you know what? Let's change this to feature pattern. I always forget that. Feature pattern. And then features to pattern, we'll choose this, the cut revolve. And then for the direction, we can maybe choose this lower edge here. I think that lower edge should be pretty consistent. And then we're going to say go the opposite direction. The distance here is going to be hashtag, and it's going to be pattern distance. So 30. And then the number of instances here will be 3. And there we go. Nice. And so maybe I want to make this a little bit easier for those components to get into place, meaning maybe I want to just create a lead in like a fillet. So S key fillet, maybe like a nice 2 millimeter fillet here. Could run that around this edge, could run it around these edges here of the of this hole. Okay, so that should make it a little bit easier for the components to enter in there. Maybe I could hide this sketch that we created, the reference to the pen, could hide that sketch. Could press P here to hide the planes. We can do S key fillet, and we can add a fillet here on these 1, 2, 3 edges. And what is that fillet radius going to be? It's going to be hashtag, and we go here to block corner radius. Enter, 8 millimeters. And then finally, one more fillet here running around the outside at the top. And that is going to be hashtag block top radius, enter, and enter. So that gives us all the geometry for that block there, that block that we're using for the hard drive and for the pen. Maybe we could hide the mate connector that we created in that part. And maybe we could right click on the name of the part down here, edit appearance. And let's make this like a green appearance. Yeah, I like that. That looks good. Maybe I can make that a little bit brighter. Go to the mixer here and see if I can't make that a little bit brighter. Yeah, I like that a little bit more. So that is, the hex code there is 80EF4B, if you want to match up with my colors exactly during this tutorial. But that takes care of that block for the hard drive, and that should kind of wind us down here into our final section of the tutorial, which is going to be to create the block for the remote control. With this one, we're going to do this one here using surfaces. So if you never worked with surfaces before, this will be your first experience, and it just gives you one more way to kind of scallop out these blocks. So if you have any questions on that last section, let me know down below. And if you're enjoying this tutorial so far, be sure to hit the like button. Hey, what's up everybody, and congratulations making it this far in the tutorial. This is editor version of TooTallToby here, kind of going through and putting some final touches on this video. And I just wanted to share with you that I am so happy that I built a physical version of this organizer. It's so nice to be able to look down and see all my tools organized and to know that each tool is in its place and to know right where to grab when I need to use that tool. So I wanted to say to you, if you finish this tutorial, please post an image of your results, whether it's the version that I created that I gave you in the tutorial, or especially if you go and make your own version using your tools. I would love to see what you come up with. So take a screen capture out of Onshape, or if you 3D print it, take a photograph of it and throw it up on the Onshape forum, put it on Reddit, put it on Discord. You can even send me a message directly with the image. I would just love to see what you all come up with, because I know there are a lot of creative users out there in the Onshape community. Okay, that's it. A short message from the editor, and good luck on completing the rest of this tutorial. All right, so the good news is we've already done this twice, so it should feel pretty familiar at this point. You're basically an old pro at this point. So we're going to create a new part studio, and the way we're going to create this part studio is using this icon here at the top of the screen. So create part studio in context. What's the origin going to be for this part? The origin is going to be the origin of the assembly. And we hit the green check mark, and that takes us into our new part studio where we've got our references to the assembly. We click on this face down here at the bottom of the red tray, and we're going to press the S key to begin a new sketch. And then we're going to get normal 2. You can press the letter N to get normal 2. And you can pick that face again, and then you can choose the use function, which converts basically that entire face into part of this sketch. And now we're going to take those lines and we're going to offset some of them. So we'll do offset here of this line, and this line. And we're going to offset them. Let me reverse the direction of that offset. And then we left click to accept that direction. And then the distance is going to be hashtag, and we will go down here to offset distance, enter, and that takes care of our offset. Now let's create a couple of lines here. So S key line, we'll make a line here that comes over like so, and we'll make a line here that comes straight down like so. And there we go. And now we can add some dimensions to locate that line. So a dimension here to this edge of the green block, hashtag, down, offset distance, enter, and a dimension here from this edge down to this line, hashtag, down, enter, and there we go. There's the geometry for our block for the remote control. And so now we can take that geometry and we can choose to extrude it. Now, the first thing I'm going to do here, I always forget this step, but I'm just going to click in the background and press space, clear my selections, and then I'm going to pick this region here. So I'm extruding the correct region. Now, in our previous example with the yellow block, what we did was we extruded it up to face and we picked that face there. Another way that we could handle this is we could do it by using our variables. So we could do hashtag, and then we could go here to our tray height, enter, and then we could say minus, and then we could go to hashtag and we could say our wall thickness. So the tray height minus the wall thickness gives us basically that same result. It's just a different way of doing it. Sometimes if you're worried that this face might go away or that you might like cut this face and change its integrity and then maybe the context wouldn't work anymore, then maybe it would be a little bit more reliable to just use the variables. So you could do tray height minus wall thickness, and that's going to basically give you the same geometric results. So hit the green check mark, and there is that block. And we can come down here to the name of the block down in the parts list, and we could shift N to rename that. We could call that block 3. We could come over here to the name of the new part studio we created, right click, we could say rename. We could call that one block 3 for remote. This is a remote control that I use to control the lights here in the studio. And then we could choose insert and go to assembly. And what are we going to insert? We're going to insert whatever's listed down here. So if this is part 1, that's what's going to show up here in this box. But it says block 3 because we renamed it. So we're going to insert block 3. So we hit the green check mark. And now we've added block 3 to our assembly. We're going to press the S key and go to group. And we're going to take block 3 and the main tray and group them together. So now let's edit this block in context so that we can reference these faces of the remote. So we're going to right click here and we're going to say that we want to edit in context. and it'll be here context 1. And kind of similar to what we did earlier, we're going to take this block here and we're just going to hide it. So hide this block here. And then we're going to use a command called surface offset. So if we go to surface offset here, let's see, can we hide this component, hide this context instance? Oh yeah, that makes it a lot easier. So we're going to go up here and we're going to search here for offset. And you've got this option here for offset surface. And what offset surface lets you do, it's kind of similar to that Boolean where you can specify a distance for the offset. So let's say we're going to offset this by, let's just stick with our 0.8 for this example. And then we can pick this face, this face, this face, this face, this face, this face, basically all the faces that are on the bottom of the remote control. This face, and this face over here. And the reason that I'm showing you this technique as opposed to just doing this thing as a Boolean, it just kind of comes back to what we talked about earlier. If you downloaded this remote control and it was a true model where it had all the internal guts, so like this lower back plate was hollow and it actually had the slider on it for the remote for the battery, and it had all the internal cavities and the PC board and you know whatever else is going on inside of this remote. If it had all of that information, then it's going to be difficult for you to do a Boolean because that other information is going to kind of get in the way. It's going to get into the mix. So when you have a situation like that, it's good to know that you can do a surface offset. Now, the one thing that'll happen that you need to be aware of is this actually creates a bunch of independent bodies. So you've got all these independent surface bodies here. Let me move up this section of the tree. So I'm looking down here. Here you can see this is the parts list. It says block 3 over here. And then also down here, you've got all your surface bodies. And if I expand that list, you can see that there are 9 different surface bodies that we just offset. So it's not that hard to clean that up. You just have to remember to do a Boolean. So if you do another Boolean here, then you could pick that first surface. You can hold Shift on your keyboard, pick that last surface that gets all 9 of them, and then you can do a union, and then that turns them all into one single surface body. And that's really what you want here because you want to use that one single surface body to cut the block. So now we've got that one single surface body. Let's show the block again. And now we can use a command. It's actually a split command. You use split to do this. So we can use the command split. And when we use the command split here, what we see is that we can choose to split using a surface. So I'm going to use this surface here. Well, you know, oh, I'm sorry, I put that in the wrong box. We can entities to split with, that lower box there. We can pick that surface. And what's nice is that we can just pick that one single surface. You know, you're not going to be able to do this with those 9 separate surfaces, or you're not going to want to do it with those 9 separate surfaces. So it's good to merge them together using that Boolean. So you just have that one single surface. And then what parts are we going to use to do the split? We're going to use this part here to do the split. And what's happening right now is we're ending up with 2 separate parts. We're ending up just kind of like slicing through, but keeping that internal cavity region. But if we uncheck this option for keep both sides, then, and here you can take this slider and you can use this slider to make it a little easier to see through here, the context. Then we can see that we can either keep just this little sliver, or we can keep the main block and get rid of that area that we're kind of slicing out. And that's exactly what we want to do here. So we're going to use that option and we're going to hit the green check mark. And there we go. We sliced out that area where the remote is. So that is a win as far as I'm concerned. And we can go back to the assembly and we can kind of see how this thing looks. Maybe we could do a Shift 5 here. Maybe we could move the remote a little bit, move it into a different position. We can right click here and say update context 1. Yeah, that looks good. Or we could click on the remote and then we could do a little rotation here like this, and then maybe drag it down here like so. And then we can right click and we can say update context. Click in the background, right click here, update context 1. And yes, that looks good. So the final steps for this thing are just going to be to add in some of those aesthetics. You know, you've got room here on this block. So if you wanted to, you could add some additional cavities here. You know, maybe you've got something else that would fit in there, maybe like a compass or a watch or a charger or something like that could fit in there. Maybe a little pocket for cables. Whatever it is that's on your desk, really, you should make this into your own and just use this first one as kind of a tutorial. But we do want to return to that block. I just want you to note here that, you know, so far what we've been doing is we've been doing a right click here and we've been choosing this option for edit in context, and that jumps us to the Part Studio. But you can also do this one here, switch to block 3, and that just takes you to this tab. Just if you have a lot of these different tabs open and you're not sure which one is which, if you haven't renamed all your tabs yet, that could also be an option. You can just right click and do switch to, and that takes you to the Part Studio that you right clicked on. So for this one, we're going to press P, that hides our planes. We're going to do S key fillet. We're going to add a fillet here to these 3 corners. What's the radius of that fillet going to be? It's going to be hashtag block corner radius, enter, enter, enter. And then we'll do another fillet here, S key fillet, and we'll do a fillet here on this edge running around the top. What's the radius going to be? Hashtag, and we can go down here to block top radius. We might also want to add a fillet here where the remote control is going to slide in, make it a little easier to slide in and out. So we could add a fillet there, maybe like a 4mm fillet running around there for that, make that a little easier. And then finally, we can go over here to the name of the block, right click, and from the right click here, we can say edit appearance, and we can make that maybe like a dark gray. I printed this one out of black and it looks really good. So we can return to the assembly, and wow, that assembly is looking good. So in the final section of this video, we'll do kind of a final wrap up. But if you've enjoyed everything so far, be sure to let us know down in the comments, and I will see you in the conclusion. And so that is basically it. Congratulations, you've done everything except for creating your 3D print of this tray. If you wanted to 3D print this tray, you absolutely can. All you have to do is right click on one of these parts right here in the assembly, and you can choose export. You can choose the file type you want to export to, maybe 3MF or STL, and then you can choose export, and here this option for download means that when you export this file, it's going to land right here in your downloads. So then you can just take that file and put it over onto your slicer and send it to your 3D printer. But hopefully you will just use this tutorial as a starting point. You will model up some of your actual parts, and then you will 3D print your own desktop organizer for your desktop. I know that I created one for myself that I absolutely love. I use it all the time, and it's just nice to be able to look down and see that everything that I need is right there in that organized tray. So I hope that you learned a lot about in-context assembly editing here from this tutorial. Your next step could be to go here to the Learning Center directly in Onshape. And once you get to the Learning Center, you could search for assembly. And in that section called assembly, there is a learning self-paced course here for managed in-context design. This course is really good and it goes into more detail. And I think that after you've gone through the tutorial that you just finished, this course will make a lot more sense. And it also has a lot more to do with having components that are moving and need to have designs created based on different positions within the assembly. So this is definitely going to be more advanced than what we went over here today, but hopefully after completing today's tutorial, this one will make a lot more sense. As always, let us know down in the comments what you thought about this tutorial, what you liked, and if you have any questions, let us know that as well. Be sure to hit the like button, be sure to subscribe, and I will see you in the next Onshape tutorial.